Hello everyone, welcome to my channel. In this lecture, we will discuss about the adsorption of lead ion with the help of olive stone adsorbent. So in this lecture, we will discuss the adsorption of lead ion with the help of an adsorbent, which is olive stone in this case. The lead ion solution will be obtained from the lead nitrate salt. These we will first of all we will make various solution having various concentration with the help of a lead nitrate, and after making solution we will put 1 gram adsorbent, which is olive stone in this case, and after that we will get adsorbent uptake percentage mole of the iodine, and after that we will plot the Langmuir isotherm and the Freundlich isotherm. The temperature for all curves for all isotherm will be 25 degrees centigrade. So it's mean that the adsorption will taking place at 25 degrees centigrade. The pH of all solution will be 6.8, and this pH will be obtained by using the dilute solution of nitric acid or HCl. So we will slightly acidic. We will slightly make our solution acidic with the help of acid. The adsorbent will be 1 gram and the volume. We will make various solution having various initial concentration. So, for example, these are the various experiments: first experiment, second, third, fourth, fifth, and sixth. We will perform six experiments. For experiment number one, we will make 0.3 ppm lead nitrate solution. For second experiment, our initial concentration of lead ion in the solution will be 2.7 ppm. For third, fourth, and so on. So these are the initial concentration of lead ion in the solution. We will make these solution in 100. We will make the solution in a glass beaker, in a glass beaker, and we will take 0.2 liter. We will take 0.2. We will make we will take 0.25 liter solution from each from each initial solution. So suppose first of all we make 0.3 ppm solution. We will take 0.25 liter from that 0.3 ppm solution, and we will perform our experiment. Similarly, after that we will make 2.7 ppm lead nitrate solution, and we will took 0.2 liter solution from this solution, and we will perform our experiment and so on. So these are the initial concentration, and the CT is the concentration of the iodine in the solution with the passage of time. So this CT will be obtained with the help of spectrophotometer. So, for example, we first of all, suppose we make 0.3 ppm lead nitrate solution, and in a beaker, and first of all, we find its concentration with the help of spectrophotometer at the start of experiment, and suppose after that we put 1 gram adsorbent in the solution, and we again measure the concentration of lead ion in the solution. So we will get 0.17 ppm solution, 0.17 ppm of lead concentration in the solution. So as you see, the concentration of lead in the solution decreases with the passage of time. It is because with the passage of time, adsorbate, which is the lead ion in this case, will attach to the adsorbent, and its concentration in the solution will be decreases with the passage of time, and it can be obtained from the spectrophotometer. So this is the concentration of the lead ion at various time, like after 2 minutes, 4 minutes, 8 minutes, even minutes, after 360 minutes. So for example, suppose we first of all make 0.3 ppm concentrate solution having initial concentration 0.3 ppm. With the passage of time, its concentration will decreases, and after 90 minutes, its concentration will become constant. So these are the equilibrium concentration. This is 0.07 for this experiment. Similarly, for this experiment, after 90 minutes, the concentration will after 180 concentration, after 1 270 concentration, after 180 concentration become constant. So this is the equilibrium concentration. Similarly, for this third experiment, the equilibrium concentration is this. This is constant. So this is equilibrium concentration. This 4.5 is initial concentration for this experiment. So from this we will find the percentry mole. First of all, we will find the percentry mole, that how much percentage, how much the iodine is removed by the olive stone in these 6 experiments. So it can be obtained from this formula. From this equation, the percentry mole of the iodine is equal to the initial concentration of iodine minus the equilibrium concentration of iodine in the solution divided by initial concentration of iodine multiplied by 100. So C naught, this is for 6 experiment, this is the C naught, this is the CE, the equilibrium concentration. Here you can see the equilibrium concentration. So is equal to C naught minus CE divided by, so divided by C naught, this one, multiply by 100, multiply by 100. So here you can see in the first experiment, 76% lead ion is removed by the adsorbent. In the second experiment, 80% lead ion is removed by the adsorbent. In the third, it is 81, and in the fourth experiment, 82%, and then in the last experiment, 65% lead ion is removed by the olive ion adsorbent. So these are the percentage removal, percentage removal. In these various experiments, these are the percentage removal by the adsorbent, percentage removal of lead ion by the adsorbent, which is 1 gram. Now this is the uptake, adsorbent uptake with the passage of time. So this is equal to C naught minus Ut and 2V divided by M. Now this C naught is the initial concentration of the iodine in the solution. Ct is the concentration of iodine in the solution with the passage of time. This can be obtained by the spectrophotometer. M is the mass of the adsorbent, which is 1 gram in this case, and V is the solution. How much solution we are using? So we are using 0.25 liter solution. So this is the volume of the solution from which the ion is, from which we are removing lead ion. So this is the volume. So from this equation we will get the adsorbent uptake. So suppose the adsorbent uptake, so it is equal to C naught minus Ut and to V divided by M. Now for this experiment here you can see C naught is this one. For this experiment, experiment number 2, C naught is this. For third experiment, so C naught for first experiment is this one. This is C naught. This is C naught of the second experiment. C naught of the third experiment, and so on. So this is the C naught. Okay, this is C naught for first experiment. So now here you can see how much point there are: 1, 2, 3, 4, 5, 6, 7, 8. 8 points. And this is the C naught. So we will get suppose a C naught for first experiment. C naught is 0.3. So it is 1, 2, 3, 4, 5, 6, 7, 8. And CT for first experiment is this one. This one. This is C naught. This is also in ppm. So it is C naught minus CT. C naught minus CT multiplied by volume, which is 0.25. 0.25. Here you can see 0.25. 0.25 liter. Okay. Divide by 1. So divide this by 1 is equal to this. Divide by 1 gram adsorbent. So again it will be equal to. So this is the QT. The QT. This is adsorbent offtake. This is the adsorbent offtake in this first experiment. Similarly, for the second experiment, you can get uh, the other. So this is the adsorbent offtake for the first experiment. Similarly, for the second experiment, this is a C naught. This is C naught. Suppose I am plotting this in this place. C naught. Okay, 2.7. And how much point? There are 8 points. So 1, 2, 3, 4, 5, 6, 8. So these are 8 points. 1, 2, 3, 4, 5, 6, 7, 8. And CT is this one. Here you can see CT. This is the CT, C naught. Now do the same process. C naught minus CT multiply by is equal to multiply by 0.25. Uh, and divide this by 1 gram. So 1 gram, if you divide this by 1 gram, you will get this result. So this is the QT for the second experiment, QT. Similarly, for the third one, C naught is 4.5. C naught is 4.5. This is C naught, and this is the CT. And again, C naught minus CT multiply by volume of the solution, 0.25. Divide by 1, so you will get the same result. So this is the adsorbent uptake for experiment number 3. Similarly for 4, this is 9 ppm. So this is the C naught, C naught, and we will get add point C naught, and this is the CT for 4th. Again C naught minus CT multiply by 2.25 divided by 1 gram adsorbent. So we will get this adsorbent uptake for experiment number 4. Okay, 1, 2, 3, 4. Now experiment number 5, 18. This is C naught. Make 8.1, 2, 3, 4, 5, 6, 7, 8. And CUT C naught minus CUT multiply by volume of solution, which is 0.25 divided by 1. So we will get this one. So this is the fifth experiment QT. Now for experiment number 6, so 18. So this experiment number 18, okay. C naught, okay. Add point, make CUT. Now C naught minus CUT. Okay. So this C naught can be higher value. This is not 18 here. I'm using this paper. So C naught here in the paper they have used the C naught. This 18, 16. This 18, 16. This okay. This is 1, 2, 3, 4, 5. So we will ignore this experiment. We will just ignore this. We are doing 5 experiments. So we will ignore this one. Ignore this one. Okay. So 5 experiment 5. It is because the in this experiment this naught value should be higher. So it should be 100 or 200, and these should be CUT because CUT is smaller than C naught. So this value can be higher. So there is some error in this experiment. So we will ignore this experiment. Okay. Now we will make the this is the Langmuir isotherm. Here you can see the equilibrium uptake. Now how can we obtain this is the equilibrium uptake? This is the maximum uptake of the adsorbent. This is the Langmuir constant, and this is the equilibrium concentration. So this is the Langmuir isotherm. the Langmuir isotherm. And this the linear form of Langmuir isotherm is this one. So if we plot, this is the linear graph, the linear line. The line is the equation for the linear graph. So this is on the y-axis CE by QE. If we plot CE divided by QE against CE, we will get the slope of the line, which is 1 divided by this one, and the y-intercept this one. So from the slope we can get the maximum uptake, and from the y-intercept we can get the Langmuir constant. This is the Freundlich adsorption isotherm, the Freundlich model. So this is the linear form of this one. Take log of both sides, so we will get log of k is equal to log of k plus 1 divided by n log of ce. So this is the Langmuir constant. N is the show the affinity between the adsorbate and adsorbent. Okay. So suppose this is the Langmuir isotherm. So once we get the Qmax and Kl, we will put Kl and Qmax in this equation, and we will plot Ce and Qe, and we will get the Langmuir plot. Similarly, for Freundlich, we will get 1 over n. We will put 1 over n in this place. We will obtain k from the y-intercept. We will put the k value in this place. These are the constant, this and this, and we will plot CE against QE. So we will get the Freundlich graph, the Freundlich plot, or the Freundlich model. This is the Freundlich model, this is the Langmuir model. So, uh, but for these plots, we should know the CE, QE, CE and QE, the equilibrium concentration and the equilibrium uptake. Okay. Now, how can you obtain the equilibrium uptake? Equilibrium uptake can be obtained from this equation. This is the Ct Qt. So if we put equilibrium concentration in this place, we will get the QE, equilibrium uptake. So Q is equal to C naught minus Ce divided by m into V. This is the volume of the solution. This is the mass of the adsorbent. C naught minus Ce into V by m. So this is the equilibrium uptake, and the Ce value is obtained from spectrophotometer. So, okay, here you can see the Ce value, Ce. From this experiment, these are the Ce value, Ce. So we will use 5 experiment. These are the Ce 0.07, suppose 0.07, 0.07, 0.5, 0.53, 0.53, 0.83, 83, and 5.6. Okay, 1.58. Okay, these are the CE5. These are the CE values, CE. Now, how can we obtain the QE value? So the QE value is obtained just like QT, and the QE value will be obtained from this equation. C naught minus CE divided by M into V. C naught minus CE. So C naught for the first experiment, C naught value is this one. For the first experiment, the C naught is this one. C naught. So C naught minus is equal to C naught minus CE Okay. Now here this is this is occur in negative. Why? The C naught for first experiment is 0.3, but this 0.25 is the equilibrium concentration for the second experiment. Here you can see this is the equilibrium for second. So for the second experiment, the C naught will be 2.7. 2.7. 2.7. And for third experiment, this is the C naught 4.5. 4.5. Okay. For fourth, it is 9. It is 9. And for fifth experiment, the C naught value is 18. 18. So these are the C naught value of every experiment. 5 experiments, C naught for first experiment is this one. The equilibrium concentration for the first experiment is this one. So for after in order to get the CE, you will perform experiment. Uh, One experiment for C naught and CE, the second experiment for C naught CE, and so on. You will perform experiments in order to get C naught and CE value. Once you obtain C naught and CE, you will get C naught minus CE, and from this C naught minus CE and to V by M. So is equal to volume of the solution is 2.25. So this is the divided by M. So this is the QE value. The QE value. The QE value. Now these are the equilibrium concentration of all experiment. All 5 experiments. These are the equilibrium of take of all the 5 experiments. Okay. Now, in order to plot the linear form of the Langmuir isotherms, you will plot CE divided by QE. Here you can see CE divided by QE on the y-axis, and on the x-axis you will plot CE in order to get the slope and y-intercept. So CE divided by QE. Okay. Now this is the CE. This is the QE. Sorry, okay. This is QE. So CEQE. Now CE by divided by QE is equal to CE divided by QE. You will get this one. Okay. This is CE by QE. We will plot CE by QE against CE. So now the CE value is okay. This is the CE divided by QE, and this is the CE. Now we will plot this one. So we will go to draw, insert, select data, add the series name is suppose Langmuir isotherm. On the x-axis, we will put CE. On the y-axis, we will put this one. Okay. So this is the okay. Okay. So add the trend line. Click on this one. Add trend line. So add the trend. This equation. Equation on this. So this is we leave this one. Okay. Leave this one. So sorry. Delete this one. Click on this one. Add trend line. Display equation on chart. Select intercept r square. Okay. So here you can see this is the linear form of the Langmuir isotherm. On the x-axis you can plot the CE, and on the y-axis you can plot CE divided by QE, and this is the slope. So the slope it is 0.1451. So this is the slope, and it is equal to 0. It is equal to 1 divided by Q max. 1 divided by Q max. 1 divided by Q max is equal to this one. So 1 divided by this will be equal to Q max. So this will be the maximum uptake. And 1 divided by Q max into KL will be equal to this one. So Q max is obtained from this one, and KL will be obtained from Y intercept. So you will get the Langmuir constant and maximum uptake. Now put the maximum uptake and the KL value in the Langmuir plot, and you will get the Langmuir plot, the Langmuir isotherm at 25 degrees centigrade. Similarly, for the front leg, you can also plot you can plot this one, this log of KV against log of CE. So this is CE and this is QE. This is CE, coffee, is equal to logarithm this one. So this is the log of CE. Okay, and QE is this one. This is the QE. Oh, sorry. This is the QE. So log of this one. Now log of this one. Now right click and insert. Okay, sorry, this one. Go to draw, go to insert, go to chart and this one. Now click on this, select data, click on it. This is the friend link, suppose. Click on x-axis. On the x-axis we are plotting log of, this is the log of CE, log of CE. And on the y-axis log of QE. This is log of QE. Click on OK. Click on OK. Now click on this one. Click on add trend line. And here display equation R square. So here you can see here the R square value, the regression coefficient is quite uh, it is near to 1. So it is from these experiments we confirm that our adsorbent follow that our that lead ion follow the Freundlich isotherm. And from these experiments, we also confirm that the adsorption of lead ion on the olive oil will follow the Freundlich isotherms because of its regression coefficient, which is quite near to 1. From these experiments, we can also confirm that the adsorbent is non-homogeneous and many layers of the lead ion will form on the surface of the adsorbent. So it follows the Langmuir isotherm, the Freundlich isotherm. And from this is the linear form. This is the slope and this is the y-intercept. So from this slope and y-intercept, we can obtain this is the y-intercept. So from y-intercept, we can obtain the Freundlich constant, and from slope, we can obtain the activity coefficient. And once we obtain these value, we will put these value in this equation, and we will make the Freundlich float or the adsorption of lead ions. So this was all about that how to make float in uh, Excel sheet. Thank you very much for your attention. If you are new to the channel, please like and subscribe.